Welcome to this explainer. Today, we're doing something really exciting. We are going to actively build a highly integrated permaculture landscape, literally from scratch. If you've ever stood on a piece of land and just felt totally overwhelmed by where to put the garden or the greenhouse or the water tanks, you are absolutely in the right place. Let's get into it.
Okay, here is our step-by-step blueprint for today. 1. Develop the nearest area first. 2. Mapping the 5 zones. 3. Identifying wild energy sectors. 4. Topography and zonal deformations. And finally, 5. Integrating elements to close loops.
Section 1. Develop the nearest area first, grounding the design.
So, we have to begin our world building at the absolute center of human activity. This grounds our entire design process in practical reality. We're relying on this foundational golden rule from permaculture co-founder Bill Mollison. Develop the nearest area first. Always start right at your doorstep and expand outward from there. Look, I get it. It is incredibly tempting to buy a piece of land and immediately try to plant a massive orchard out at the furthest edge, right? But by developing the area immediately around your home first, you completely avoid that super common trap of spreading your time, your money, and your physical energy way too thin. You've got to secure your core, make it highly productive, and just let your success naturally ripple outward.
Section 2. Mapping the 5 zones. Organizing human energy.
Now, let's overlay our very first transparent layer onto our base map. A zone is basically a conceptual area, and it's organized by its proximity to the center of activity and the frequency of human use and maintenance. So I want you to imagine a beautiful watercolor wash of concentric circles radiating outward from your home. What we're actually mapping here isn't just physical distance. We're literally mapping your internal human energy and exactly how often you're going to need to visit a specific space just to keep it thriving.
You can really see the transition of intensity here. In Zone 1, which is right outside your kitchen, you're probably visiting multiple times a day for things like culinary herbs or, say, checking on delicate seedlings. Then you move outward to Zone 2 and you're visiting maybe every few days for poultry or small livestock. By the time we hit Zone 4, we are only visiting seasonally for things like managed woodlots or timber. And then finally, Zone 5. That just fades out into completely unmanaged wilderness. It's a natural sanctuary where nature does all the work, and honestly, it's a great place to go when you just want to be left alone to observe. By placing our high-maintenance items close to us, we drastically conserve our own energy. It's just smart design.
Section 3. Identifying wild energy sectors, the external forces.
All right, so we have our internal human energy mapped out, but now we really need to overlay the external, uncontrollable forces that are constantly sweeping across our site. Unlike our human-centric zones, a sector is a compass direction, or a wedge, outlining where these external, wild energies actually enter and flow through your property. Picture these broad, sweeping wedges of yellow, blue, and red watercolor cutting directly across all those concentric zone circles we just drew.
So what exactly are we tracking here? We're looking at summer and winter sun arcs, prevailing cold winter winds, hot summer winds, water flow, and flood-prone areas, wildfire vectors, and even wildlife migration corridors. The whole point is that by synthesizing these incoming vectors onto your map, you can actually consciously design your landscape to deal with them. You could erect shields, like a dense tree line to block a freezing north wind, or you could open up a clear sector to let that low winter sun passively heat your home.
Section 4. Topography and zonal deformations, morphing the map.
Okay, since real land isn't a perfectly flat piece of paper, our pristine, concentric circles now have to morph to fit the actual Earth. This is where the theory really hits the dirt. Step 1 is identifying topographical features, things like your primary valleys, steep ridges, and contours. Step 2, you want to place key infrastructure intelligently. For example, contour roads should be placed high and dry on the ridge crests so they're easy to maintain and they don't wash out into the valleys below. And then step 3, we deform those circular zones into lobular patterns that actually conform to water flow and slope. For instance, a frequently visited Zone 1 path might extend like a long finger along a flat contour line, whereas a really steep, inaccessible ravine right near your back deck, well, that might instantly become a wild Zone 4. By stretching our zones out to accommodate high ridgeline roads and the natural pull of gravity, our map becomes this dynamic, living shape.
And as we deform these zones, we are going to abandon straight lines entirely. We want lobular, wavy, and zigzag edges. Why? Because the edge where two systems meet, like a forest and a meadow, or land and water, is known as an ecotone. And the ecotone is literally the most biologically diverse and productive area in nature.
By replacing those rigid boundaries with sinuous, crenellated edges, we absolutely maximize this edge effect. Think about it like the wavy folds in our intestines, drastically increasing the surface area for nutrient absorption. Wavy garden edges do the exact same thing, creating incredibly productive microclimates along our deformed zones.
Section 5. Integrating elements to close loops. The magic of connection.
So, we've got our zones stretched across the topography and our sectors are all mapped out. Now we lock it all together. Notice the really stark contrast between traditional, segregated agriculture and permaculture integration here. In a segregated system, the components are totally isolated. Your inputs, like fertilizer, have to be imported, and your outputs, like animal manure, well, they just become a polluting waste problem. But in an integrated system, everything cooperates. It's like a puzzle. The outputs of one element directly feed the inputs of another, and that creates the absolute maximum number of beneficial connections.
Let me give you an elegant example of this. This is based on one of Bill Mollison's foundational design templates, the chicken in the greenhouse connection. So the chicken breathes out carbon dioxide and radiates body heat, right? Well, that is exactly what the greenhouse plants desperately need on a cold night. In return, the greenhouse captures solar energy to offer daytime warmth, shelter, and surplus vegetable waste for the chickens to eat. It's brilliant. You aren't doing the chores anymore. You have essentially hired your chickens and your greenhouse to take care of each other.
This kind of functional integration proves a massive point. System stability is determined by the density of supportive connections, not just species diversity. It is not enough to just have a greenhouse, a chicken coop, and an orchard placed randomly somewhere on your property. True ecological resilience comes from how tightly you synthesize and weave these loop-closing connections together across your deformed zones in your mapped sectors. Every deficit in an element's input creates extra labor for you, and every unused output creates pollution. Smart integration literally solves both of those problems at once.
So, to wrap up this explainer, I want to leave you with a challenge. Step outside and really look at your own landscape. What wild energies are sweeping through your space right now? And more importantly, what two elements can you integrate today to close a loop, reduce your own labor, and mimic the absolute genius of natural ecosystems? How are you going to synthesize these layers of zones, sectors, and integrated elements to create your very own thriving, regenerative base map? Thanks so much for joining me today, and I seriously can't wait to see what you design.